Hi, I'm Luke McKinney, Prep 101's Physics 101 instructor, and in this video we'll be practicing reading graphs with the examples of displacement and velocity graphs.
The ideas of displacement and velocity are often used in graphs, and graphs let us measure something in that the slope of any graph is the change of the vertical axis, the y-axis, over the change in the horizontal axis, the x-axis. Now we know the change in anything is just the second point minus the first point. So we'll have a quick look at this before we go into the big example. Let's say I have a graph which is the hours spent playing Apex Legends, which I like to do from time to time. And so on the x-axis is then days. So 1 day, 2 day, 3 day, 4 days. And the hours spent, I get to 10, but it's just 0, 0, 0, and then 10 hours. So if we were to look over the whole period between here and here, what do I have? I have the new value minus the old, new value minus the old. So that's 10 hours minus 0 over the fourth day minus the 0 day. So that's 2.5 hours per day, which sounds pretty good and pretty fun. But you can see that's not actually what happened. That's the average between the second point and the first point. So it's a useful value, but that's not actually what happened. So that's the average value. If we instead want to look more specifically at what happened, we can take the instantaneous value that lines up with this point going along there. So now we'll call that 2 and 1. So now the second value minus the first, the second value minus the first. So that's 10 minus 0 over 4 minus 3. And that's 10 hours a day. And that lines up exactly with the curve at each point. And we can take that as the instantaneous value at each point. The answer to this riddle, of course, being that that day is Saturday, woohoo! But working today instead. So that's the idea of the y-axis over the x-axis. I find a lot of these things are easier to picture if you use a value you already know and like as a sort of test. Now, another value we already know from the previous primer is the idea of displacement. So if we look at this graph now of displacement against time, the first thing you could do with any graph in a question is just to read the graph and see what the story is before you try and answer it. So this object started at 0. It was moving in the plus direction up to 20 meters. Then it stopped there for 20 seconds. Then it was moving in the opposite direction, in the minus direction. Remember, in physics, plus and minus are just directions, and displacement, well, displacement, I should go that way, so displacement is a vector. Then the object started going in the plus direction, then going in the plus direction faster and faster and faster. So we could even suspect now it's accelerating. So let's look at that now in terms of what we just saw. So we have displacement against time. That means the slope of this graph is the change in displacement over the change in time, which is the velocity. So the slope of this graph at any point is the velocity. So if we take the slope at this point, we can see that's a straight line. The slope isn't changing. So that's a constant velocity. And we can work out the velocity. We take the second point and the first point. So the change in position over the change in time, new position minus the old one, new time minus the old one, 20 meters minus 0 over 20 seconds minus 0. So that's moving at 1 meter per second. But we can take it between any 2 points. For example, if we take it between here and here, so that's our second point, that's our first point, we'll find the average velocity, even though it stopped for a while. So in that case, the new position minus the old, the new time minus the old, so that's 20 meters minus 0 over 40 seconds minus 0. So the average velocity is now much slower. And at any point, we can see the slope of the line is the velocity. So for those first 20 seconds, we have a positive constant velocity. Then for the next 20 seconds, it stopped. So that's 0 velocity. Then it has a negative velocity, and that's much steeper. So that's a greater value, a bigger velocity in the negative direction. And now, if we look at this last section from 60 seconds on, we can see at this point, the instantaneous velocity, a tangent to that line, is 0. At the next point, we have a bigger velocity. At the next point, a bigger velocity. Next point, a bigger velocity. So the velocity is changing. And we always just break it down into terms like that. We say, oh, the velocity is changing. That means it's accelerating in that region. Because any change in velocity is an acceleration. We've been talking about velocity for a bit, and that's the other type of graph we can get in this part of the course, the velocity versus time graph. So we've got a new graph. As always, before you dive into any big theory or questions, you just read the graph to yourself, because the graph is there to help you. It's a tool of some information. So we see this had a constant velocity of 1 meter per second. Then it dropped to 0 velocity, so it stopped for 20 seconds. Then it had a negative velocity for 20 seconds. And then the velocity started increasing from 0 onwards. So this is actually the velocity time graph for the previous graph. And we can do the same trick. Remember, the slope is the change in the y-axis, which is the velocity, over the change in the x-axis, which is time. So this is the acceleration. Now we can find the acceleration at any point on this. For example, if we want to see this region that's accelerating here, we call that point 2 and point 1. The acceleration is the change in velocity over the change in time. New velocity minus the old, new time minus the old. So that's 1 meter per second minus 0 over the new time, 100, the old time, 60. We see that's 1 over 40 meters per second squared. So not a very big acceleration at all there. But there's another trick we can do with this sort of graph, which I wanted to show you here. For a velocity versus time graph, and I've taken a new clean one there. You never try to do two things on the same diagram, otherwise you end up with nothing clearly done at all. The displacement, we remember, is velocity times time. So the displacement is just the area under a velocity time graph. You can just color in this region here, and the displacement is that area under the velocity time graph. So in that position, the displacement is, it's 1 tall by 20 seconds wide. So that's 20 meters it's moved. Because basically taking the area, coloring in under a graph actually is integrating the whole function. This is what integration is, which seems scary to a lot of people, especially with calc courses, but this is what it basically just looks like. Now we just remember, if we're carrying on, that if we look at this area underneath 0, that bit of displacement is the height, which is minus 2 meters per second times a width of 20 seconds. So that's minus 40 meters. Now we'll see other places later in the course where this works as well. You can find the work as the area under a force distance graph. We're not doing that yet in these primers, but it's a nice little resonance, so I thought I'd mention that as well.
I hope that was useful. There's plenty more videos in the playlist, but what's even more useful is lots of exam examples and exam specific advice. And that's what we do in the prep sessions. So join the Prep 101 Study Hub Facebook page to find out when those go on, and many of them are even free, so you definitely don't want to miss those. Hope to see you there.